Hello, Honors Precalc. Picking up where we left off yesterday, today's notes are going to be called polar graphs. So you can title your notes that. And our first problem asks us to graph the following equations on polar graph paper. You can use the graph paper that I gave you on, what day was that? Tuesday. Then convert each equation to rectangular form. So first we have r equals 6. And notice how it doesn't give us an angle. All it tells us is that r equals 6. So if we say this is 2, 4, 6, so 6 is our last concentric circle. All this basically is just a circle. Because again, it doesn't tell us the angle. So at all of these points is where r is equal to 6. And that's our graph. And to help us make sense of this, I'm going to remind you of yesterday when we were converting from polar to rectangular or from rectangular to polar. We said that r squared was equal to x squared plus y squared. So writing that down here, r squared equals x squared plus y squared. We know that r in this equation is 6. So 6 squared equals x squared plus y squared. And what we get is x squared plus y squared is equal to 36. And we should all recognize that this lovely shape is a circle. Sorry, this lovely equation, I should say, forms a circle. So we have a circle here with a radius equal to 6, centered on 0, 0. All right, and this second problem, this tells us theta equals pi over 4. So in this problem, it gives us the angle. It doesn't give us the radius. It doesn't give us that r value. So to do this one, pi over 4 is this angle. And maybe you can already predict that this is going to be a line. This is actually going to continue through the origin to the other side. So we have a nice little line there. So to convert this, it's currently in polar form. We need to get it into rectangular form. A reminder from yesterday, tangent of theta is equal to y over x. In this case, tangent of pi over 4 equals y over x. Well, tangent of pi over 4 is just 1. So we get 1 equals y over x. When we solve for y, we get y equal to x. And that is the equation of that line. This is a line with a slope of 1 that goes through the origin. Okay, so I've given you these two equations that we talked about in yesterday's video. And today I want to remind you of those other two equations. X is equal to r cosine theta and y equals r sine of theta. And we're going to use those in this next problem. Number 2 says convert the following equations to rectangular form. So A has r equal to 3 secant of theta. So what we want is we want to get r cosine theta or r sine theta so that we can replace these with either an x or a y. Now the nice thing is this is secant of theta, so if I multiply that by cosine, that's going to give me 1. So multiplying both sides of the equation by cosine of theta, I'm going to get r cosine of theta on the left side and 3 times cosine of theta times 1 over cosine of theta. That's just the reciprocal identity. These cosines of thetas cancel out, r cosine of theta we know is equal to x from this equation that I mentioned over to the right. So we have x is equal to 3, and we've successfully converted this into rectangular form. So all this is, x equals to 3 is just a vertical line at 3. All right, now looking at B. B, we have r equals 2 sine of theta. So again, what we're trying to do in this, we're either trying to get r cosine theta or r sine theta. We already have our sine of theta, so we're going to multiply this whole thing by r. And on the left-hand side, we get r squared. On the right, we get 2r sine of theta. Well, what's r squared equal to? If we look up here, we already said r squared is equal to x squared plus y squared. And we're ultimately trying to get this equation into everything in terms of x's and y's. So we have x squared plus y squared is equal to 2y, because r sine of theta is equal to y. All right, getting everything on one side of this equation, you might recognize this as some kind of conic, or yeah, some kind of conic shape maybe. So we have y squared minus 2y. Let's complete the square here. B over 2 squared. So b is negative 2 divided by 2 gives us 1 squared. So that's 1. So I get x squared plus y squared minus 2y plus 1 equals 1. Remember, whatever I do to the left side, I have to do to the right. And then I'm going to factor everything with the y's. So x squared plus, this becomes y minus 1 squared equals 1. And what we're looking at, maybe you recognize this, this is an equation of a circle. This is a circle with radius 1 and center at 0, 1. So here's the center right there, and it has a radius of 1. It's going to look something like this. Just like that. Okay, and we have our answer. In this next problem, the equation is given to you in rectangular form, and it's asking you to convert to polar form. And I have a little hint here for you saying solve for r. So you might think, okay, we're given x plus y. I know that x squared plus y squared is equal to r squared. So what if we squared both sides? Well, let's see what happens. We get x squared plus 2xy plus y squared equals 25. X squared plus y squared we said was equal to r squared plus 2xy equals 25. But then we still have this xy business going on. We need everything in terms of r's and thetas, so we're not going to do that. But what we can do, we know that x is equal to r cosine theta, and we know that y is equal to r sine of theta, which is equal to 5. And then we just simply solve for r by factoring out r. And we get r equals 5 divided by cosine of theta plus sine of theta. And that's our answer. Now, what's interesting about this equation in rectangular form is y equals negative x plus 5. And you all know what that looks like. It's a line that goes through 5 with the slope of -1. What's cool is that if you graph this equation down here in polar form, you end up getting exactly that line on your polar graph. So I don't know, just kind of a neat little thing. So what we're looking at now is that sheet that I gave you on Tuesday after your test. We're going to actually graph functions in polar form. So we have this equation, y equals 2 plus 2 sine of x. And if we were going to graph this, we know that our axis is y equals 2. It shifts up 2 because of the plus 2. We know that the amplitude is equal to 2, and we know that the period equals 2 pi over b, which is 2 pi over 1, so the period's just 2 pi. Okay, so labeling this, we're going to say this is 2, 4, 0. This is pi over 2, pi, 3 pi over 2, and 2 pi. All right, let's think about this. When x is equal to 0, sine is equal to 0. Sine of x, I should say, is equal to 0. Then we add 2, and we are at that point right there. When x is equal to pi over 2, we get sine of pi over 2, which is equal to 1, times 2, which is 2, plus 2, we're up at 4. So this first part of the graph goes like this. All right, and then I'm going to do this next part of the graph in a different color. You'll understand why later. But when x is equal to pi, we're going to come back down. Like this. When x is equal to 3 pi over 2, we're going to look like that. And then when x is equal to 2 pi, we come back up. Let's see what would be a good color here. Let's use the sky blue color. Come back up to this point. Okay. What I also find helps is if we do a little chart here and we do r and theta, and we're going to change our original equation to y equals, or I'm sorry, not y equals. We're going to change this to r equals 2 plus 2 sine of theta. Okay, so when theta, which was previously x, when we say that's 0, r is equal to 2. When theta is equal to pi over 2, r is equal to 4. And what I like to do, actually, before I write that one down, let's think what value of theta, when we take the sine of that angle, are we going to get 1/2? Well, we know that's pi over 6, right? We can just use the left-hand rule for that. So sine of pi over 6 is 1/2 times 2 is 1 plus 2 is 3. So at pi over 6, r is equal to 3. And then that value that I wrote before, so at pi over 2, we get r equal to 4. And let's find all of the multiples of pi over 6. So we get, or rather the ones that occur in each quadrant. So pi over 6, we know 5 pi over 6 is in the second quadrant. So that gives us 1/2 again. It's going to take us to 3. Then we're going to look at pi. 2. And if you're wondering where these numbers are coming from, just look at the graph, right? At pi returns 2, and that's where I got this value here. All right, so that's why I like to draw the graph and create this table, because they kind of work in tandem to come up with these values. Let's see, so we're now into the third quadrant, which gives us 7 pi over 6. So now sine of 7 pi over 6 is -1/2. -1/2 times 2 is -1. 2 minus 1 gives us 1. Then we have 3 pi over 2. That's negative 1, which according to our graph down here, 3 pi over 2 returns 0. Then we have 11 pi over 6 because we're into the fourth quadrant. 11 pi over 6 is also going to return 1. And finally, 2 pi gets us back to 2. Okay, now we want to graph this. Taking a look down here, this says graph the polar graph r equals 2 plus 2 sine of theta. We're always between 0 and 4 with our values seen here. These are all between 0 and 4. So on our polar graph, we can say that each concentric circle is equal to 1. So this is 1, 2, 3, 4. All right, then we're going to plot our points. Now, I did this color-coded so that you can see on the polar graph how this corresponds to our rectangular graph at the top. So at 0, r is equal to 2. So this is my first point right here. At pi over 6, r is equal to 3. So this is pi over 6, remember. R is going to be equal to 3. And at pi over 2, r is equal to 4. So pi over 2, r equals 1, 2, 3, 4. All right, that's our first part of the graph. Now, this is going to end up, well, I actually won't draw that yet. Let's just get our points down first before we connect all the points. All right, so continuing on to the red section. The red section is 5 pi over 6 is 3. So 5 pi, this is 5 pi over 6. 5 pi over 6 is 3. So that's 1, 2, 3. And then pi is equal to 2. So pi we're equal to 2. You kind of see this coming together. It looks like it's going to be maybe symmetric about that y-axis. And then continuing to our green section, we know that 7 pi over 6 is equal to 1. This is 7 pi over 6 is equal to 1. And 3 pi over 2 is going to be equal to 0. So that's our origin right there. And then the sky blue color, 11 pi over 6 is equal to 1. 11 pi over 6 equals 1. And 2 pi returns us back to 2. So then we return back to there. Okay, so now let's connect these points. When drawing these, it can always be a little bit tricky. It's always going to be a little bit more circular than you think. So this one here, we're going to swing out, connect these, and we're connecting these points in order. So we come up there. That's that blue section that we graphed up in the rectangular graph. That's what it would look like down here. Now we're going to graph the red section. All right, it's going to come down here. Again, try to make it as circular as you can. It's always more circular than you think. That's that red section. For the green section, we're going to follow it down here, and it then hits that point and it comes back to the origin. All right, and then the sky blue section does the same thing on the opposite side and comes back to where we started. And that's our graph. So if we look, oh, let me zoom in a little bit. There we go. If we look at a comparison of these two graphs, What you see above is this equation graphed in rectangular on the rectangular coordinates, and down below on the polar graph. We're going to do more of this tomorrow. For your homework tonight, take a look at homework number 2. I understand if the graphing stuff might be tricky, but like for the converting between rectangular and polar equations, you should be able to do that. Do your best on these graphs. Don't stress out if you're like, you know what, I have no idea what this is supposed to look like. At least get it down, and we're going to do more of this tomorrow. We'll finish up that packet that I gave you on Tuesday. So with that being said, have a great rest of your Thursday, and I'll see you all tomorrow.